The correlation coefficient, or R, measures the strength of the relationship between the two variables used in the model. R can be any value in the interval between -1 and 1 included, and the sign of R will match the sign of the slope. So what we're really talking about when we talk about how weak or strong or how highly correlated something is do they have a strong or weak relationship? So I've actually provided you here with 5 visual representations of the correlation coefficient. So when R is -1, this means a perfect correlation. So this is a line with negative slope, and every single data point is falling on the line. Here we see a little bit more of a scattering, but we can still see that the values are trending down, right? So we would say this is moderately correlated. So there is some kind of linear relationship going on, but the values are pretty spread out. And so this would be an R value of about -0.5. A zero correlation means we can't detect any relationship at all when we look at the data plot. And you can see this is just splattered all over. There's no discernible relationship between the two variables. But here, if we say 0.85, right, well, we can clearly see these values, right, trending in a positive direction. And they're a little bit tighter and closer. We can kind of almost visually see where the line would go in this. So here, if we were to have a line of best fit, it might look something like this. Here, our line of best fit might look something like this. And you can see the data points here are a lot closer to the line than they are over here. And so that would indicate a stronger R value. And then on the opposite extreme of the spectrum, right, we have an R of +1. And that, once again, is a perfect positive relationship. So every single data point actually is already linear. So that it's very rare that you ever get things that are perfectly correlated. So these two, right, represent a perfect linear relationship. All data points lie on the line, okay? So this almost never happens in real life, but occasionally if you've got those models we looked at in the previous section that were already linear, they would have correlation values of 1. So it's just telling you how strong or weak. One thing to keep in mind, this is a really strong positive relationship, but if I gave you a R value of -0.85, that's a really strong negative relationship. So the only thing that would change would be that the lines would just slope this way, but the points would get closer to the line. So the stronger or larger the number value of R is, the closer the data points get to your line of best fit, which is reducing the error. So what is the correlation coefficient for the model of our data set that we did? And what can we say about the two variables in this model? So if we go back on our calculator, I'm going to clear this out, and we go back to Stat, Calculate, and we go down to Linear Regression, right? And once again, I'm going to L1, L2. I don't need to send it to Y1. I've already sent it to Y1. I just want to see the model again. So this should come out. R squared has a different meaning. We're actually going to talk about that in a future chapter, but we just want to look at R. And so our R value for this model is 0.9578. And I would usually take this out to about 4 decimal places. So this is a positive value. R is very close to 1. So I would conclude that since R is very close to +1, there is a strong, the word strong or weak comes from the value of the number. Positive matches the sign of the number. Relationship between X and y. So a strong positive relationship, right? And we saw that the slope of our line was positive. And if we actually plotted these data points, we would see the points would be very, very close to our line of best fit. So if we if we now say, well, suppose that in that data set we've been looking at, the number of people, X is the number of people in a room, and Y is the total of $1 bills in their pockets. So we take everybody in the room, we have them empty their pockets, and we add up how many $1 bills the room together has, right? And it says how many people should be in the room to have $150 in $1 bills. So it's asking, well, can we predict the number of people we would need in order to approximate, right, what would be 150? So if we take the model, there's two ways we can do this. We could take our model, which was 6.41x minus 283.98, and we could set that equal to $150 and then solve for x. However, there's a better way to do it. We actually sent our line to y1. So if we go back to our calculator and go to graph, okay, right now I can't see it, so I'm going to zoom zoom standard first just to get it back in line, see if we can see the line. I still don't see the line, which kind of makes sense because the y-intercept was really, really small. So now I'm going to go to zoom fit. And remember, it just adjusts the y values so we can see the line. And there's our model, right? But now if I go to y equals and I plug in $150, I want to graph and I want to know, well, when are these two going to intersect? So we're going to have to play around with this for a little bit. So if we go back and look at our window, well, we know on our data set that the lowest X value we had was 63 people, and we saw that the biggest X value in our data set was 75 people, and we can see that somewhere around in here is probably where we would hit 150, right? Because we had 142, 162, 156. So somewhere around in here. So I'm going to set my X value. I'm going to say let's go from 60 to 80 people. So I'm going to set this at 60. I'm going to set this at 80. And now I'm going to graph. Let it do its thing. And now I'm going to try to zoom fit again. And so now it should recalibrate the Y values so I can see both graphs on this. So we can see there's our model, there's 150. So now if I go to second, calculate, intersect, it grabs the first line, the second line, it says guess, and we see it's 67.667 people. So X is 67.667 people. And since I can't have a piece of a person, you always round up in a situation like this because 67 people isn't enough people according to the model to have $150. So we would need to make sure to guarantee that we have that extra person in the room. So we would need about 68 people in the room if we wanted to try to pull $150 together. So now try the practice on your own problem, and I will see you for Chapter 5.